Welcome to the Explainer. Today we're going to do something kind of cool. We're going to shrink ourselves down and take a trip inside a modern rifle. We're talking about a mechanical ballet, a super high-speed chain reaction that's over in the blink of an eye. So let's get into it and see how this thing really works.
So, you pull the trigger and a whole lot happens in just a split second. But what is actually going on inside this machine? Well, you can think of it as a perfectly controlled miniature explosion. It's this incredible chain reaction, a whole series of events timed down to the millisecond that harnesses that explosive power to launch a projectile with just amazing precision.
Okay, so to really get our heads around this, we need a good example. And boy, do we have one. We're looking at a true masterclass in modern firearm design, the FN SCAR-H. Now, this isn't just any rifle. This thing was built from the ground up for the toughest conditions you can imagine. Its insides are just a perfect example of elegant and, more importantly, super reliable engineering.
Now, the real secret sauce, the heart of the SCAR, is this brilliant system. Sounds complicated, right? But the idea behind it is actually kind of simple. It uses its own explosive energy, the gas from the cartridge it just fired, to power itself. It basically recycles its own energy to get the next shot ready almost instantly. It's ingenious, really.
And this right here, this is the fuel that makes the whole show go on. The cartridge. Each one is its own little self-contained package of potential energy. You've got these four main parts: the casing, the primer, the gunpowder, and the bullet itself. They all work together in this beautifully simple design that, believe it or not, has been tweaked and perfected for over 100 years. It just works.
Now, this is a great visual because you can really see the difference in scale here. That round on the right, the 7.62 NATO that the SCAR-H uses, it's just visibly bigger than the stuff you'd find in an AR-15 or an AK-47. And that size difference isn't just for show. It means more room for gunpowder, which translates directly into more energy, more velocity, basically a whole lot more power when it reaches the target.
All right, so we've met the tool and its fuel. Now let's get into the main event, the chain reaction. We're going to break this down step by step, even though the whole thing happens way faster than you can blink.
Okay, so before any of that automatic magic happens, there's one thing you have to do manually to get the ball rolling. You pull back the charging handle. This single action does two really important things. It grabs the first round from the magazine and shoves it into the chamber, and it cocks the hammer back. It's kind of like winding up a spring-loaded toy. You're storing up all that potential energy, getting the machine ready to go.
And here it is, the cascade of events. It's so important to get this. Pulling the trigger doesn't actually fire the bullet. Nope, it's just the first domino to fall. That trigger pull releases the hammer smacks the firing pin, the pin hits the primer, and boom. You get a tiny explosion that ignites the main gunpowder. It's this beautiful, violent chain of physical strikes and chemical reactions, and it all happens in an absolute flash.
Now, as that bullet is hurtling down the barrel, something amazing is happening. See those spiral grooves? That's called rifling, and it's one of the oldest and, frankly, most brilliant tricks in the book. Those grooves force the bullet to spin like crazy. We're talking thousands of rotations per second. It's the exact same reason a quarterback spins a football. That spin gives it gyroscopic stability, which is just a fancy way of saying it keeps it flying straight and true, instead of tumbling end over end.
So, the bullet is gone, screaming towards its target. You think the job is done, right? Well, not even close. The work inside the rifle is only about halfway finished. Now comes the really clever part: harnessing the aftershock of that explosion to get ready to do it all over again.
So how does that happen? How does it go from bang, with a hot, empty shell sitting in the chamber, back to having a fresh round loaded, locked, and ready to fire all on its own? The answer is just so clever. It redirects a tiny puff of the same gas that just pushed the bullet out.
And this is where that gas system we talked about comes into play. Check this out. As the bullet flies past a tiny little hole in the barrel, a little bit of that high-pressure gas gets siphoned off. That gas slams into a piston, basically like a battering ram. That piston shoves the whole bolt carrier backwards. As it moves back, it yanks out the spent casing and throws it out, resets the hammer for the next shot, and then a big spring shoves the whole assembly forward again. On its way forward, it strips a fresh round from the magazine and chambers it. It's a violent, super fast, but perfectly choreographed cycle. Okay, so we've got the single shot down. One pull, one bang, and it's reloaded.
But, military rifles like the SCAR have different modes. So how does a single little switch on the side completely change the gun's behavior from one shot at a time to, well, a whole lot of shots? Let's take a look.
So how does one little switch have so much control? It's all about a tiny but absolutely critical part called the sear. The best way to think of the sear is as a little hook or a catch that holds the hammer back. So on safe, it's simple. A piece of metal physically blocks the trigger from moving. Can't pull it. On semi-auto, when you fire, the sear catches the hammer after the shot, so you have to let go of the trigger and pull it again to fire another one. But here's the magic of full auto. When you flip to that mode, the selector switch physically holds that sear down and out of the way. That means as long as you're holding the trigger, the hammer is free to fall again and again every time the bolt cycles. It's a simple but brilliant mechanical trick.
So when you put all of these pieces together, the power of the cartridge, that lightning-fast firing sequence, the genius of the gas-powered reloading, and the clever fire control switch, you're left with a truly remarkable piece of modern technology.
But here's what's really wild to think about. The SCAR is made with space-age polymers and high-tech alloys, right? But the basic mechanical principles it runs on, things like gas operation, a rotating bolt, a hammer-fired system, those ideas are not new, not at all. They were pioneered almost 100 years ago. It just goes to show you how brilliant that foundational engineering was.
So really, the story of a modern rifle isn't about some brand new invention. It's a story of refinement. It's about taking those rock-solid, century-old ideas and perfecting them, using modern materials and manufacturing to make them work together flawlessly. That's why it's so powerful and reliable, because every single part in that mechanical ballet does its job in perfect harmony.
And that kind of makes you think, doesn't it? What other modern marvels do we use every single day that are still running on principles that are 100 years old? I mean, think about the internal combustion engine in your car, or maybe even the mechanics of a classic wristwatch. We're literally surrounded by modern tech powered by old-school genius. It just proves that sometimes the most elegant solutions are the ones that really truly stand the test of time. Thanks for joining me on this one.